Hey, what's up guys? This video is for section 3.3 rate of change. It is the second part, so this is the second video. If you haven't watched my first video, go ahead and do that and then come back to this second part. So we are talking about rate of change. Let me just take this out of the way here. Rate of change is a ratio that describes how much one quantity changes with the respect of another quantity. Some people say the average rate of change or short just rate of change. Now, rate of change is when you have, like I said, a ratio or a fraction, and in that fraction, you guys are comparing some type of quantities. In algebra, what we are comparing are the x values and the y values. How are they changing when you guys have a graph or when you guys have different points? So the average rate of change, or just the regular rate of change, is when you have the change of the y values on top of the fraction and you divide by the change of the x values on the bottom. Now, rate of change is also called the slope of a linear function. The slope is the rate of change in a non-vertical line. Now, you guys learned that vertical lines, they have an undefined slope, so we don't know what it is. But anything that is not vertical, that it actually has a slope or a line that it is slanted, it's going to have some type of slope, which is the rate of change. The changes of the y's divided by the changes of the x values. The slope right here is when you have a variable m, and that's what we use, and it can be represented as rise over run. Now, in my first video, I explained how that works in a graph. You go up, down when you have a rise, and then the run is when you go to the left or to the right. But today, we are actually going to use the slope formula to find a specific variable or a specific value. So look at the actual formula for slope. y2 minus y1 divided by x2 minus x1. Now, this formula works when they give you guys 2 points that are on the line, and you can find the slope. Or using that formula, we can find a specific value if we are missing one of the numbers. So let's go ahead and do some examples where they give you guys a couple points, they give you guys the slope, but we have to find that missing value. So notice here that we have some examples, a few examples, and we want to find the value of r so that the line, the linear function or linear equation, passes through the points and it has the given slope. So let me make sense of what this is when you look at the problem. They have 2 points. The first point is -3, -4. So we know that the line that we graph, if we graph, we're not going to graph it, but if we actually graph it, it's going to cross, it's going to go through this point, the -3, the -4. And the second point it has to go through is -5, comma, r. Now that's the number that we are looking for. We need to know what number works in this space, so all of this actually makes sense. Plus, the line has to have a slope of -9/2. Since we have the slope of the line and we kind of have the 2 points that are on the line, once again, we are missing one of the numbers, but we can use the slope formula to find that missing value. So let me go ahead and write down the formula on the screen. So the formula, once again, is m, the slope, equals y2 minus y1 over x2 minus x1. I already labeled what the numbers represent in each point. So this is x1, y1, because it's the first point, 1, 1 first. And this is x2, y2, because this is for the second point, 2, 2 means second point. And we know what the value of m is. So all you do, guys, you are going to substitute this fraction into your m, your slope. So I'm going to do that right now. I have a -9/2. Now, this is very important. If you have a slope that is not a fraction, go ahead and make that number a fraction. So you just put a 1 under the number. Because eventually, we are going to have what is called a proportion, and to solve proportions, we're going to cross multiply. So we need a fraction equals a fraction. So remember, if this number is not a fraction, you go ahead and convert that into a fraction. Now this is going to equal, and let's go ahead and substitute the numbers into the formula y2 minus y1. So y2 is r minus y1 is negative 4, so I need parentheses, so I put that inside the parentheses, over x2 is negative 5, minus x1 is also negative, so I need parentheses again, and you simplify what you can. So we do have what I call double negatives right here, which means you have a negative times a negative and also on the bottom. So that's going to turn positive. So I'm going to have negative 9 over 2 equals r plus 4. And on the bottom, you have negative 5 plus 3. Now, I want you guys to pay attention of what's happening. On the bottom of the fraction, we can still simplify the negative 5 plus 3. On the bottom. On the top, you have that missing value. R is missing. So that is the number that we are looking for. So in order to actually solve for that variable, we want to get R by itself so we know what the answer is. I'm going to simplify the bottom of the fraction. One more thing. On the left side of the equal sign, I do have a negative 9 over 2. Now, this negative next to the fraction gets a lot of students confused because they don't know where the negative goes. And some students, they actually think that the negative goes to the top and also to the bottom number. So they put a negative 9 and a negative 2. That's not true. That's incorrect. That negative only goes to one number. And I tell my students to take the negative to the top number. So I want you guys to do that if you are in my class. So I'm going to put that negative on top. I'm going to have negative 9 over 2. So I took the negative to the top. Can you guys take the negative to the bottom? Yes, you can. Just make sure the 9 stays positive. But in algebra, it's not very common to have negatives on the bottom of the fraction. So that's why we take it to the top. On the other side, I'm just going to simplify the denominator. So I have r plus 4 over negative 2. That negative 5 plus 3. This is a proportion. We have a fraction equals a fraction. So we are going to cross multiply to solve the proportion. So I am going to multiply the negative 9 times the negative 2. And I'm going to put that here so we know what we are multiplying. And I'm going to bring down the equal sign. And now I'm going to multiply the 2 times r plus 4. So I'm going to put 2 times r plus 4 here. You guys keep going and solve for r. So on the left side, we get positive 18. On the right side, I am going to distribute the 2 to the parentheses right there. So we're going to have 2r plus 8. And you don't have fractions anymore. You guys can solve for r. So we subtract 8 from both sides. That's going to be 10 equals 2r. And finally, you guys divide by 2. So we get 5 equals r. Or we can say r equals 5. This turns into invisible 1. We don't need it. So my answer, the value that I'm looking for is 5. That number is going to work for those 2 points and to have a slope of negative 9 over 2. So let me just zoom out here to show you guys this number 5 needs to be here in order for all of this to work. So let's try the next one. Now here, you guys actually need to pay attention of the slope, especially the slope, because here it says that we have an undefined slope. So first of all, we need to understand what that means. But let's go ahead and write down the formula, the slope formula, and then we can talk about the undefined slope. So, undefined. The slope of undefined, now that I have that formula, I can substitute what that means. Undefined is when you guys have a fraction for your slope and you have a 0 on the bottom of the fraction. That's what it is. If you have a fraction and a 0 on the bottom, it's going to equal undefined. So you put a 0 on the bottom. Now, the top number, it can be any number, because mathematically, any number divided by 0 is going to be undefined. But the easiest number that you guys can use is just 1. So you can put a 1 on top of the fraction and you'll be okay. It's going to give you guys the correct answer as long as you use any number. But don't try, once again, don't try to use big numbers or numbers that make everything complicated. The number 1 is the best one to use. So I'm going to put a 1 here. I know that 1 divided by 0 is undefined. So that is my slope. Now I am going to label my numbers, and I do have the x1, the y1, the x2, the y2, and go ahead and substitute into the formula. So right there, I have the numbers already substituted into the formula. Go ahead and simplify what you guys can. So here, you guys cannot simplify the 1 over 0. Over here on the top, you guys can subtract 5 minus 4 is 1. And on the bottom is going to be r minus 3. Now you guys cross multiply. So I will multiply 1 times r minus 3. So I put 1 times r minus 3. And notice that I am multiplying the 1 times everything, r minus 3. And that's what you do when you multiply a binomial. That's what it's called when you have two terms. And on the other side, you bring down the equal sign. 0 times 1 is 0. Now when you guys distribute 1 here, 1 times r is just r. 1 times 3 is 3, so I put minus 3 equal to 0. And finally, you add 3 to both sides. Cancels, r equals 3. So that is my value. My value of r has to equal to 3. But let me emphasize in the slope. When you guys have undefined slope, make sure that you guys have a 0 on the bottom of the fraction. And it's very common to get that 0 mistaken, because some students put the 0 on top of the fraction. And we'll talk about that in a second. But for this example, since the slope is undefined, you put a 0 on the bottom. And then you guys set up the formula, cross multiply, and solve for the missing variable. Now this one here, look what happens in the points. Those 2 points, they're actually missing one number, r, comma 3, and 5, comma r. Now my slope is 0, not undefined. So we actually have to be careful with that because we are going to have a 0 in a fraction, but we have to understand where the 0 goes. So let me write down the formula first, the slope formula, and then we'll talk about the slope. So in the formula, I'm going to substitute 0 into the actual slope, but I'm going to make it a fraction so I can cross multiply when I have proportions. So I'm going to bring down my equal sign here. There's my fraction. And when the slope is 0, in the fraction, you need a 0 on top of the fraction. Remember, we just talked about undefined slope. That's when 0 is on the bottom of the fraction. But this one is not undefined. This slope is 0. So you need the 0 on the top. Now the bottom number can be any number that you guys want, but the easiest number that you can use is 1. 0 divided by 1 is 0. Okay, you guys can use a 7 on the bottom. You guys can use a negative 20. But the easiest number is 1. Now on the other side, I'm just going to label my numbers and substitute the values into the formula. So you see the x1, y1, x2, y2. I substitute those numbers in the formula, and I have 0 over 1 equals r minus 3 over 5 minus r. Notice that I cannot simplify the numerator or denominator in this fraction, but I am going to cross multiply. So when I cross multiply, I multiply 0 times all of this right here, the 5 minus r. So I use 0 parentheses, 5 minus r. I multiply everything by 0. And obviously that's going to equal to 0. Anything times 0 is 0. And on the other side, I'm going to multiply 1 times everything up here. 1 times r minus 3. And I'm using parentheses because I am multiplying all of that, r minus 3 times 1. Let's go back to the left side. So anything times 0 is 0. And on the right side, you guys will distribute the 1. So 1 times r is r, and 1 times 3 is 3, so minus 3. You guys add 3 to both sides over here. So you guys will have 3 equals r, or we can say r equals 3. So this number here, r equals 3, is the number that's going to make sense, that actually works for that example or this problem. This r has to be 3. This r has to be 3 as well, because that's the value that we found. M, once you put 3 here and 3 here, the slope m is going to equal to 0. So it's going to work. So you guys have to be careful with the undefined and the slope of 0. So let me just zoom out here because I want to make sure you understand the difference. And undefined slope is when you have a 0 on the bottom of the fraction. So the number on the top doesn't matter, but you guys have a 0 on the bottom. And a zero slope is when the zero is on top of the fraction. And the bottom fraction doesn't matter. I mean, the bottom number doesn't matter. But the top number has to be a zero. So that's how you find a missing value using the slope formula. You guys set up the formula, you substitute the numbers that you have, that you actually know, and then you guys just cross multiply, simplify, and then cross multiply, and then just solve for the variable. So that number that we found, remember, we are looking for that missing number in that specific point for R. And the last thing I want to talk about is actually finding the rate of change, or you can say slope for linear functions from a table. Now you guys use the formula when you have two different points. You can use the slope formula to find m, which is the slope. But when you guys have a table, I'll show you guys what you can do to actually find the rate of change, aka slope. But first, let's go ahead and read what I have on top of the screen. To determine if a function is linear from a table, find the first differences of the x and the y values, then check if they are the same value. Now what I'm trying to say is I want the values of x's to be, the difference of the x's to be the same every time I find that difference, and the y values, the difference in each y value also have to be the same. So I want to determine if those tables are equal. So when I say the difference for the x and the y values, I want to know what is happening to each table. So let's look at the first table here. We have x to be 1, y negative 6, and then 4 negative 8, and so on, and so on, and so on. So the differences for the x's, so I'm looking from 1 to 4, I want to know what's the difference. 1 to 4, the difference is 3. In other words, you are adding 3. Now from 4 to 7, you are also adding 3. From 7 to 10, you're adding 3. And from 10 to 13, you're adding 3. So that is the difference of the x's. And since you guys found the first difference, you can say they're the same because we have a 3, 3, 3, and 3. That's what we want. Now for the y values, we also have to do the same thing. I want to know how do I get from negative 6 to negative 8, from negative 8 to negative 10, and from negative 10 to negative 12, and from negative 12 to negative 14. So here, I need to subtract 2. Now let me explain why. Because from negative 6, and you subtract 2, negative 6 minus 2, that's negative 8. Negative 8 minus 2, that's negative 10. Negative 8 minus 2 is negative 10. And negative 10 minus 2 is negative 12. And negative 12 minus 2 is negative 14. So that is the difference of the y values. So you guys can see that the x differences are equal all the time, and the y differences are equal all the time. So first of all, we can say this is a linear function. If you guys actually plot the points and you connect the points, it will make a line. So I'm going to write that down first. Yes, it's linear. I know it is linear because of that difference for the x's and the y's. They're all the same for the x's, and they're all the same for the y's. Now, to find the actual average rate of change, which means the slope. When you guys have a table and you are looking for the slope, all you need to look for is for the change in the y's over the change in the x values. So what is the change of the y's? What is the change of the x values? Well, the change, the pattern, the number that you guys are using every time in the y's is negative 2. So that is what the change of the y's is, negative 2. And the change of x's is 3. So you put a 3 on the bottom of the fraction. So my average rate of change for this table, m, which is the slope, is negative 2 over 3. So we know it's linear. It is going to be a line if you plot the points and you connect the points. And it has a negative slope, negative 2 over 3. Now let's look at this one here, okay? Because sometimes just by looking at the table, you can't really say it's linear. Some people can do that, and some people can actually find the slope by looking at the table. But you actually have to do a little bit of work to make sure that we did the correct work or the correct steps. So I'm going to check the x differences here, okay? I want to know what's happening to the x values. So from -3 to -2, I'm actually adding 1. From -2 to -1, I am adding 1. -2 plus 1 is -1. Now from -1 to 1, wait a minute, I am not adding 1. If you guys add 1 to -1, that's going to be 0. Here, you're actually adding 2. -1 plus 2 is +1. But the next one, 1 plus 1 is 2. Now the only problem is this value right here. That number, since the x differences are not the same every time, we have a number that is different, that 2. That means that this table is not linear. Now let me show you guys the y values, because even though if the y values work, from 11 to 15, you're adding 4. From 15 to 19, you're adding 4. From 19 to 23, you're adding 4. And from 23 to 27, you are adding 4. It works for the y values. But even though if that happens, but the x values, the difference are not the same, we say that this is not linear. And since it's not linear, it means that we don't have a slope, okay? We have other type of function. It might be a different function, quadratic, or it might be something else, cubic, polynomial functions, anything. But we know it's not linear because the first differences of the x's and are not the same in this table. You guys have a different number here, a 2. So that's how you actually find the values in the table. So let me just emphasize this, because it's really important that you understand how do you know it's a linear function. So we know this is not linear because the x differences are not different. On the previous one, the x values, you're always adding. Let me put a plus here so you know that we're adding 3. So 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. And 10 plus 3 is 13. So it is 3 every time. And for the y values, you are subtracting 2. So we have -6 minus 2 is -8. -8 minus 2 is -10, and so forth and so forth. So that's why we can say it's linear. All right, guys, so this concludes my video here. If you guys like my videos, you can hit the like button. You can also subscribe to my channel. Make sure you guys also practice, and I'll see you guys later.